Hello! Today we're going to solve this problem that is part of the module 2.8.2 in your textbook. And what it says is they give us a matrix A and the determinant of another matrix that you get by doing computations with A and B. And we know that that determinant is 32. And out of that we want to figure out what is the determinant for B. We have these options, so we're going to do our procedure and figure out which one among these options we are going to get. Okay, so we have A and this new matrix equals 32. So what we're going to use, if you look into our textbook in section 2.8.2, you're going to find theorem 3, which is basically the one that we're going to use to solve this problem. And it tells you these properties of the determinant. So the determinant of a product of matrices, I changed a little bit the notation by the way, is equal to the product of the determinants. Something important, matrices do not necessarily, when you do the product, it doesn't commute. So the matrix PQ might be different from the matrix QP, but still the determinants will satisfy this equality. And if I have a constant K multiplying an n by n matrix A, then the determinant of this new matrix is k to the n times the determinant of A. Finally, in that same part of our textbook, you will see a rule that if you play around with this first property, you can figure out this formula that tells you that the determinant of the inverse of a matrix is just 1 over the determinant of the matrix. So let's use this into that. So what do we have? I have the 32 is the determinant of this. And if you see, I have an inverse here. So using this rule, this is the same as having 1 over the determinant of now this matrix that is inside of the square brackets. And I'm going to put this parenthesis here. Okay? So I still have 32. And now I'm using the property that the determinant of a product equals the product of the determinants. So this can be decomposed into 1 over the determinant of A inverse square times the determinant of B inverse, but the determinant of B inverse is just 1 over the determinant of B. Okay? And we're going to do one more step to simplify this part. So this is 1 over the determinant of A inverse square is the determinant of A inverse, this number square, and then I'm just going to put this one underneath here, over the determinant of B, right? This is still 32. And my last simplification is this is going to be 1 over the determinant, actually, 1 over the determinant of A inverse will be 1 over the determinant of A. This quantity is squared, and this one is divided by the determinant of B. Okay, so all of these can be simplified, right? So this tells you we want to solve for the determinant of B, right? So this tells me that 32, just simplifying this fraction gives me the determinant of B divided by 1 over, this is 1 square over the determinant of a square. And we can do the computation for this number. So if I have a equals to this, what this tells me, let me put that here, is that the determinant of a is, we can do the computation, 1 times -4 minus 2 times -4. So that gives me -4 plus 8, so that's 4. So I'm going to substitute here 4. One over 4 to the square. And then I'm going to solve for the determinant of b. So this multiplied here. So we have 32 over 16 is the determinant of b, which tells me that the determinant of b is 2. And this one is the option C. So the answer for that problem is indeed C.